Alright, so now we are on the last problem of section 12.7, higher order derivatives. This is problem number 38. Marginal revenue. If P, so we have a demand function. If P equals, this is actually an inverse demand function because price is a function of quantity. So we have 400 minus 40Q minus Q squared. The question is, how fast is marginal revenue changing when Q equals 4? So again, we need to get marginal revenue, and then we need to take the derivative of marginal revenue. But first we need a revenue function, so we need to multiply P times Q, which is going to be our total revenue. So it's going to be 400Q minus 40Q squared minus Q cubed, and that's going to be our revenue function. So our marginal revenue, dr dq, is going to be 400 minus 80Q minus 3Q squared. That's going to be our marginal revenue. Now the question is asking, how fast is marginal revenue changing? So that means we need to take the second derivative of this revenue function. So d2r dq2, that's just the notation for the second derivative, equals the derivative of 400 is 0 minus 80 minus 6q. So now we need to evaluate the second order derivative at the value Q equals 4. So we plug in Q equals 4, and that gives us negative 80 minus 24, so that's minus 104. Essentially what this is saying is that at a production number of 4 units, the marginal revenue, if we produce one more unit, the marginal revenue will change by 104 units. So it'll go down by 104 units. And that's it. That is the answer to this question, and that is the last problem for this section. The point of this section again is just to get familiar with the fact that you can take derivatives of derivatives, and that those also have some meaning, because when you take a derivative, you're basically creating a function that will give you the slope of the tangent line at any point on the curve, and that function is changing, and thus we can then analyze how it's changing if we take further derivatives. We're done here.